Okay, so the very first thing that you're going to do when you start an latex document is you want to determine what document you're actually writing. So there's various types of papers out there. You might have read a couple where it's either two column, single column. They're all in different types of format. So what latex actually lets you do is it lets you just put all your words, equation, figures into a document compiler. And what it does is it actually properly structures your papers. It will reference all your figure numbers from 1 to n all in a row and update all your references as you go along. So it's actually a very handy tool to learn, and it trumps Microsoft Word as well as Google Docs in terms of creating a professional document. So the first thing you're going to start out is you're going to define a document class. So what we have is we have a conference paper. So this will be a 2-column IEEE paper. And we are going to override the command lockouts. And then the first thing you got to do is you have to begin your document. So the very first thing, as I said, a backslash denotes the start of a command. And everything that you do in Overleap is going to start with a begin statement as well as an end statement. So we're going to begin our document. And in that, we need a title for our document, in which we'll call project template. And then we need an author. So I will just put my name in there. And then once you're done this, you make a title. And then in Overleaf, you can press Control S. And what it will do is it will compile your project. So what you see on the right-hand side of your screen is this is a PDF that's now downloadable. If you're using TextMaker, it would be available in the exact same file location as your .text file. And this is what you're going to go through and build your project on. So in order to be up to the IEEE standard, I'm just going to copy the example author block that you saw if you downloaded that folder. So this is your basic template for an IEEE conference paper. And so now you got to start writing your paper. So with these papers, you always have a abstract at the beginning, and this has a 600 word maximum. As well as it should outline everything from your introduction all the way to your conclusions and a bit of your results. So I believe in a lot of reports you have to do an executive summary. This is very similar to that. In this case of the paper, they just call it an abstract. And then the next thing that you're going to add, again, we always start with a begin statement and end with an end statement. We have IEEE keywords. And what this is going to do is if you were to go forward and publish your paper, this is what makes you stand out on Google Scholar. So let's say somebody is looking for a paper on mechatronics and maybe an ankle-foot orthosis. You can put these keywords here. And that is actually what the Google Scholar, as well as any other paper, is going to index in order for you to find the best papers. So again, if I do Control S, it saves and compiles, and this is what we have on the right for our paper. So you have your abstract, which will always be in bold. That is the formatting that IEEE states, as well as your index terms. So once you're done that, and may I add, the abstract should be the absolute last thing that you ever write for your paper. Make sure everything's good to go, and then write your abstract. It makes it a lot nicer to read. So to start writing your paper, generally, if this was a Word document, you would start with an initial heading and then continue to write everything underneath. So latex works in a very similar manner, except everything that you do is called a section or a subsection. So your first section will be your introduction. And in this section, you introduce your system, state what's been done before, and what you are going to change. And again, if you go and compile that, it'll automatically give it a number 1 beside introduction, as it is your first section. And then as you go throughout, it'll automatically label your headings as you go through. So that being said, there's sections. You can also do subsections. So as well as subsections. And this allows you to stagger as you would in a regular document, how you would go throughout and write all your information. So all of this is pretty basic in terms of writing the document. There's not too much of an advantage right now that you can see. However, the big advantage comes when you start doing citations as well as figure numbers and equations. So to start off, let's look at a citation. So let's say you read a journal article and you determine that somebody said that this 3D printed stepper motor has the best torque. You would go and you would include that in your literature review part of your section, and then you would include a citation. And within the citation, what you're going to do is you are going to you're going to go to your .bib file. You can name this file whatever you want, as long as it has a .bib behind it. And this will be an empty bibliography file. And what you do is you would go and you would actually find this article. And what's really nice about Google Scholar is you can go to this Cite button down at the bottom right. And what you're going to click on is bib text right here. And this will give you everything that you need to put into your citation machine. So some of you might have used EndNote in the past. This is very similar to this, except it's all just text-based. There's no importing, exporting. So you copy and paste this into your citations, save and compile your citations. And what you're going to do is, see this top line here? This is the name of your citation, so you can reference it in your main paper. So I'm just going to rename it. Just so you can see it. And what you're going to do is you're going to copy and paste it into here. So what you can see is when you compile, you have a question mark where your citation goes. This is because we actually haven't included the citation or the bibliography into our document. So we're going to go ahead now and do that. So again, like I said, because it's latex, we have to include the bibliography into your main document. So first you have to determine which style that you want your bibliography. So it's an IEEE paper. So it's going to be an IEEE translation style. And then you're going to include a bibliography. And what this actually references to is your .bib file. So I'm going to name mine citation because this is citation.bib. And when I compile the file, we now have a reference 1 as well as you have your reference down at the bottom side of your screen. So as you would go through and you do your literature review, you're going to have multiple citations. Let's say you have the second citation that we just copied. You can include it in and it'll automatically update your references. So that's one of the big benefits that Latex has. So again, if you're doing your literature review, you might want to go forward and include a figure of your device. So to answer your question, you can put all your citations in the .bib file. So you can have from 1 to 1,000. There's no real limit on those citations, so you just include the one citation.
Sorry, I have one question.
Yep.
Although it might be looking into what you'll be talking next. Will you be talking about formatting and stuff?
Yeah, so I'm now going to talk about figures, tables, as well as anything like that.
Okay.
And then essentially what this IEEE translation at the top does is that does all the formatting for you.
Okay.
So you won't ever have to state that this section will be section 1, this section will be section 2, or this figure will be figure 1, figure 2. It'll automatically do all of that for you.
Okay.
That's sort of the benefit of this system. All right, so again, we're going to add a figure now. So we start with a begin, and again, a figure. Another nice thing about Overleaf is, again, the autocomplete. And so what I did here was I saved a whole bunch of figures that we can include. So a benefit here is we can specify the width of our figure. So I'm going to set it to 0.45 of the page width. I believe it's text width. And so what that means is the width of your final picture is going to be 0.045 times the width of your final paper. So it'll fit in one of your 2-column paper. And then what you're going to do is you're going to specify the path to your figure. So in this case, I have a folder called figures, and I'm going to do afo.png.
How did you load those PDF and PNG files on the left?
Okay, so that's really easy. You just right-click on the folder, select New File, and you can upload it from anywhere on your computer.
Oh, okay.
All right, so I'm going to include this, and what we're actually going to see now is we're going to see an error. So it's not a distinct error, but what you see is you can see this width equals 0.45, etc. And that's because we're not including the proper packages that are required to actually compile the document. So what package we're going to include is the graphics.x package, and this allows you to load figures into your document. So now we have a picture of a AFO in here, and what it does is it already references it as figure 1 because it's the very first figure in your paper, as well as it allows you to do a caption. So I'm going to say a standard AFO. And an important note with figures is they must be very descriptive. So as you go through writing your papers, don't just say, okay, this is an AFO. Describe what it is. So looking at this, as I write the caption, I'm going to say it's a standard polypropylene AFO. And it says it is comprised of a footbed as well as a shank that's connected with a Scotty joint in between. So you want to be very specific about what's happening. So if somebody is skimming over their paper, they know exactly what the figure is there for and what it's representing.
Sorry, can you go back to the package we have to include?
Yes. Sorry, it's called Graphics X.
Graphic.
I got a quick question too.
Yep.
It looks like it does what I think it does, but when you put the width as 0.45 of the page, this like IEEE translation, like the formatting, was already taken into account, making sure we have the borders that regular pages do. It's not 0.45 of actually the whole page, but rather usable space.
Yes, that is correct.
Okay.
So
thanks. And that's taken into account by the IEEE translation or one of those formatting things.
Yes, so this very top statement here, this document class, states the margins and everything around it, as well as that this will be a 2-column paper.
Awesome, thank you.
Okay.
And I saw someone else shoot a message in the chat box.
Yes, so that's actually a very good question. Why does it go to the top? And so what you can actually specify is that you can specify that it's at the bottom. So it's going to shift it to the right-hand side, center for the top. And so using these square brackets next to the figure, you can actually format where you want your figure. But in personal preference, as well as what I've done so far, is if you let Latex position your figures throughout the document, it sort of works a lot better. The document comes out in better chunks, or else you might get, let's say, 4 to 5 sentences of text, and then a picture in the middle of it, and then another section of text. And so that becomes an issue. As you're reading the paper, it sort of breaks it up. So generally, I just leave it, and it will position itself. And so an important part of this package right here is, see this label command right here? It says label fig my label, so I'm going to call this AFO. And what this allows you to do is reference this figure wherever you are in the document. So you might be in the conclusion, you might be in the introduction. And there's one question about saying, how would you get the figure on the text editor? So back to the text editor here. So I will pull up, let me just give me 1 minute. So this is the example template that's actually on the Google Drive. And so what you have here is you have your text file as well as all your log files. And so you're just going to make a figures folder in the exact same folder where your .text file is, and then post your figures in there. So it's very similar that if you're programming, you have to be in the same directory. And hopefully that clears up that question for you.
On overleaf on line 40 in your code,
yep.
Right after it says text with close bracket, say you put figures and then like the / with afo.png. Did you like type in afo.png, or is there a way to like quickly kind of get that in? Because if your image has like all numbers and like a weird name, it takes forever to type it in.
Yeah, so you do have to type it in. So all I'm doing is I specify what folder it is and then what the name is. It won't autocomplete for you.
Okay, I see. Right, thank you.
So getting back to this label, so we have a fig.afo label, which allows us to reference the figure wherever we are in our text. So let's say we want to include the figure, or an AFO can be seen in figure, and then you're going to reference it from within the paper. So Overleaf comes up with it, and it says reference fig AFO. So if you go and you compile the document once more, what you're going to see is it automatically links it to figure number 1. if, let's say, we had 3 or 4 or 5 figures, it'll continue to update it every single time you go through. And so that's what makes LaTeX very handy in this way. So you don't have to, at the end of your paper, go through and label the figures 1 through 10, etc. Is there any questions with including figures? Okay, so the next thing I'm going to do is I'm just going to quickly go over stuff like bullet points as well as lists. I don't use it that much in what I do, although you might want a list per se that you're going to design for a low-cost solution as well as an easy-to-manufacture solution. So to do that, again, you start with a begin statement, and then enumerate is a list from 1 to how many items, and you have to specifically determine which every single item. So item number 1 is going to say reduce the power required. Item number 2 would be reduce the weight, etc. And again, as you compile it, you have your list 1, 2, 3. If you want to do a sub list within that, again, you just start a new enumerate section, and you can say power is weight. And see, as you compile through there, it makes it pretty easy as you go through as once you know the commands. The same thing you can do if you want a bullet point. So that would be an itemize. So you're just going to label a whole bunch of items, and I will do the same thing or have the same statements throughout that. And again, when you compile, you'll have a nice bullet point at the bottom. If you want to do sub bullet points, you use the exact same methodology. So is there any questions with what we've been going over so far? So first, we've went over figures as well as lists and bullet points. So the next big thing that you're going to be using a lot of is equations. And this is sort of what makes LaTeX very handy compared to Word equations or Google equations that you've used in the past. So very first thing you're going to do is begin an equation as well as the end statement. And let's say power is equal to voltage times current. So something very simple. And what you see on the right hand side of your screen is it already puts it in a math format, and it already gives it a number behind. So as you go through, you no longer have to list all those numbers and so on. Again, with an equation, you can also add a label to an equation so you can reference it as you go throughout your text. So I'm going to call it equation power. Then at the bottom, I'm going to say, or above the equation, I'm going to state power is calculated as shown in, and then you can do an equation reference. You can either reference the equation in this manner by putting parentheses around the reference, or you can reference it in this way, which is an equation reference.
Sorry, could you zoom in again on the text, please? Thank you.
And what you're going to notice here is that equation reference actually requires a cite package in order to be used. So I'm just going to include that at the top. So either one of these references to the equation below suffices. So you either have to put parentheses around it and reference it like any other label, or you can do a respective equation reference.
is there a way to comment stuff out so it doesn't have an effect as we're learning, and you're like, oh, is this how you do this? Or could I also do this? You know what I mean? Like
Yep.
commenting something out so it doesn't have an effect?
Yes, exactly. So a percent sign is a comment. I should have led with that to start, but anything with a percent sign is a comment. Anything with a backslash is a command. And anything besides that will be text that you go through.
Thank you very much. Thanks.
No problem. Okay, a very important thing to note when you're writing equations, although it might seem very obvious to you as you're writing it, you need to specify what every single variable type is throughout the text. So you can't just state power is equal to voltage times current. You and I know that because we're in the mechatronics field. However, there might be somebody who's reading a paper who they can see V as a volume value and I as some other value. So every single time that you include a calculation within your text, you want to state where P is power, V is voltage, and I is current. Okay, you'll notice one thing that I did right here, and that is I put dollar signs around the P as well as the V and the I, and this is known as in-text equations. So technically I could write a full equation in here, the P is equal to V I equation, and it will be included within the paragraph of my text. So one allows you to label and give spacing for your equation, and the other one just allows you to state a simple equation within the text. So is there any?
If we were, or sorry, were you about to ask if there's questions?
Yeah.
I was wondering if we're, like, for example, to have just put the cash signs instead and you did all the equations, would that be incorrect because you lose the ability to use the functions that equation has because we're not within the equation, like, subsection? If you know what I mean? Because, like, you could put cash signs and write out equations, basically, right? But we lose, like, the ability of those functions?
Yeah. So a big thing that starts out is the... Okay, yeah, there is some good questions in the chat as well. So the first thing that you would lose out on is the formatting that the equation actually gives you. So if you notice on the right-hand side, it's going to give you space, write your equation, give you a reference number for that equation, and number your equation, and then it's going to start the paragraph below, so it's nicely formatted. If I did that here, and let's say I split it up, it's going to left justify the text and not center it or give it a reference number in any way, shape, or form. So that just allows you to, either way, I hopefully that answered that for you.
Yeah, it does. Thank you. Thanks.
And the importance of putting all your variables between the dollar signs is so that they're reflected exactly in the text as they are in the equation. So if you did a plain P, as in power, what you'll notice is these two P's are very different. One is in the math style and one is in the text style. So you got to make sure that as you go through, whenever you declare a variable, you need to ensure that it has dollar signs around so that you keep consistency as you write your paper. So again, there was a question in the chat about what happens when you do a more complicated math function. So I will add that in here.
Could you do like the quadratic formula as an example, like how you would enter that in?
Yep. Well, how about this? I have one example here which I can show you. It's got all the Greek letters in it.
Okay, yeah, that's true.
In it as well. Okay, so starting off, this is a steady state transient current equation. So you have a I, which is your current, and let's say you want to put a subscript to your I. So you want to say I naught. So you're going to do I underscore in curly brackets 0. and that gets you your respective subscript as you go throughout. You could technically add all your anything that you want within these two brackets. Let's say I current, and that will show up below. Another method that you could do is if you only have one character behind it, you can do I not, and it'll give you a subscript. But if you wanted to do I12, it won't actually allow you to put the 2. So that's what these containing brackets allows you to do. Okay, so again, we have I naught is equal to frac, which is a fraction. And what you're going to do is in the first brackets, you are going to put your numerator, and in your second brackets, you're going to put your denominator. So I'm going to take the square root of 2 vs all over z. And if we just compile this real quick, you see you have a nice function below. If you wanted to include the vs within the brackets, all you got to do is move it over, and it automatically formats everything you do. So again, if you wanted to do the quadratic equation, you can do a to the power of 2 is equal to sqr square root that again will show up properly. Again, if you want to put anything besides one character in a subscript or a superscript, you have to put those brackets around your equation. Similarly, if you want to include sine or cosine, it's just backslash sine in your brackets. Let's say we will put theta, and it'll be included all in here. What I can do for you guys is I can upload a PDF with all the Latex math equations in it. And what you can do is you can go through this document and it'll tell you exactly what you need to do for every single command to get your result. So let's say you want to have interesting brackets throughout, you can include that as well as any interesting symbols you might need. So that will go on Canvas at some point, and we'll include that, as well as I believe Dr. Rosa has put a link in the chat where you can also see all those sort of commands throughout. So is there any questions in regards to the math equations?
It's not about equations, just like a general format question.
Okay.
So is there only like, because you know how you said in the beginning that that IEE trans thing kind of like does the formatting for the whole document?
Yep.
So does that take into account like font, what gets bolded, text size, and everything too?
Yes, exactly. So it'll do everything that you need to do in terms of the IEEE. So it'll bold any sections that need to be bolded. It'll put the math font into the correct font, as well as your font size and everything you need to do there. And so it just really helps throughout that.
So for this course, as long as we have that one the one package at the top, we're pretty much okay, right?
Yes, exactly. So as long as you have that package, as well as there was a report template that was on Canvas. Yeah. As long as you have all the base information from that report template, you should be good to go.
Okay.
And then if you run across any errors, just let me know and I can help you out with that for sure.
Question.
Yes.
Is there a way, like, if I wanted to make something like bold or underline or italic, can I still format it like by choice?
Yes. So what you can do is you can say So let's say you want this to show up in bold. Again, you use backslash because it's a command. And then you say text, bold font that you see right here. And then everything within these brackets will now get bolded. So you see that result there, as well as italics, text it. We'll do the exact same thing. So if you run into anything like that you want to, let's say you want to underline a piece of text, etc., just a simple Google search will actually either bring you to Stack Overflow or Overleaf, and you'll have the answer within seconds.
All right, thank you.
No problem. Is there any other questions? No? Okay, going forward, I'm just going to have a look at tables now. So tables, another helpful thing that you are going to use. Yep.
For equations, instead of using fraction, like if I just wrote square root of 2vs, and can I write like the divide sign and it would still write it as over z, or no?
No, so it's got to be very specific. So let's say we got rid of this, and I put a divide there, and put this at the back. First of all, I have one too many brackets. 1 second.
Okay.
Say divide by z. Yeah, your equation shows up as followed, which isn't correct in that term. So make sure you always use the fraction and multiplication as you go through.
All right, thank you.
The next thing we're going to do is we're going to start a table. So again, Overleaf is nice. It automatically will give you everything you need to do. An important thing to do or to note when you're creating tables, especially in Overleaf when it auto-generates everything, your title as well as your reference number for your table has to be at the top. So to do that, the simplest thing you do is you just take this caption and you move it above tabular. And it'll now be on the top. And you can say, my table 2021. And again, we have this label, tab, my table, and you can use that to reference a table from wherever you are in your text with that reference.
Sorry, what was the original issue again? It was that IEEE this formatting puts the caption at the bottom, but we want it to be on top?
Overleaf does that. So like when you start when I say begin table here, it's going to give me a basic table structure that I can use, and it puts a caption on the bottom. IEEE translation actually says that it must be at the top, but since this caption is stated at the bottom, it's going to put the number as well as the caption at the bottom of the table. And so to fix that, all you have to do is bring your caption to the top, and now it'll put it at the top of the table.
Awesome, thank you.
All right, now we're going to look at the formatting of your table. So what you have is begin tabular within your table, and you have these C's. So what C actually stands for is centering. So let's say I want to create a 3x3 table, and I want lines on every side, sort of like what you would see in an Excel file. So what I'm going to do is I'm going to put a upright, a C, which means we're going to center our first column, another upright, a C, which means we're going to center our second, and then our third column as well. And then what I'm going to do is I'm just going to type in 1, the and sign, 2, 3, 4, okay, so before I compile this, I'm going to let you know that the and sign is the separator between what goes in which column. So we're going to put 1, and then in the next column 2, the next column 3, and then this double backslash that we see denotes the next line of the table. So I'm going to compile that for you. And it's showing up, as you can see, like this in a regular table format that we specified. So let's say you want to put a heading on top, as well as you want lines between every single one. In terms of taking an Excel file or CSV and automatically importing it into LaTeX, I've never done it myself. There might be ways to do it. However, if you're taking that much data and putting it into LaTeX, it should be pretty significant data that you're showing. You don't want to show mass tables of results. A figure would be much better in that case. You would just want simple results in a table that you could quickly reference and go that way. So I believe on Canvas there is a tips and tricks page which sort of tells you how your figures should look in comparison to others, as well as tables and data. But what I would recommend is keep your tables very small so the user doesn't have to scour for the data all the time, or the reader in this case. And then try show everything in a concise figure that doesn't take up too much room. So again, going back to your table, let's say you want a top line with a header and so on. What you can do is you can do H line, which stands for a horizontal line. Header 1, header 2. And again, the double backslash denotes the next line. You can do another horizontal line to separate the header from the actual values. And that, at the end, you can do a final horizontal line. So then your table looks like that, which is a much more nice and readable. There's other packages out there that are actually very nice to use, and I'll represent one of those to you, and it's generally what most people use nowadays. So I'm going to include another package here. It's called Book Tabs, and what I found through my research is that this actually formats your tables the best. And so I will show one example of this as well. So instead of specifying these lines at the top, I'm just going to have 3 columns with no lines on either side. I can specify a top rule for the top of the table, a mid rule for the middle, and then a bottom rule for the bottom. And when you compile it, you can see the table looks much better and much more professional in that way. So again, if there's no questions with results to tables, then I will keep going. We don't have very much left. Is there any other questions?
Is there a way to put like lines between like each row?
Yeah, again, if you wanted to use it this way, you can just do mid rule, or at the top, you can just do horizontal line. Either of those works.
Okay, thank you.
As you can see, the mid rule here actually adds more space between your values, whereas at the top, it just puts a straight line in the middle. And again, if let's say we want to left justify the first column, I replace the C with an L, and everything is left justified. So if you want to do something in LaTeX, there's generally a way to do it. All you have to do is a quick Google search, and it will come up relatively quickly. So in that regard, this is sort of a basic overview of how LaTeX works. Is there anything you want me to go more in depth into?
I was just wondering, when you like put a title in the like curly brackets for a section, does that just title the section, or does it actually trigger something in like the like IEEE format to format it as an introduction if you call it introduction?
So the only one that does that is the abstract here. So beginning abstract and end abstract, that'll format it all in a special way. But in terms of a section, it will always format it in the same way. So let's say we want to go to, we'll add a couple more sections at the end. Let's say design and results. What you'll notice is, first of all of these will number after each other, and they'll all be the same format no matter what.
Okay, thanks.
No problem. Is there any other questions? Can you change the font and font size? So you can, and you can actually specify it up in the top. You could go 12-point font. And as you can see, everything's much bigger. But in terms of this project, do not increase your font size or anything like that. Like, just make sure your document class has this exact statement at the beginning, because that's the format that we expect the paper to be in. So it should be as small as this when you read through it. Again, if you wanted to see what it looks like with one column instead of two, you can go and you can see all that. However, for this project, it has to be a 2-column paper in this format. Okay, is there any other questions with regards to LaTeX? Okay, and in terms of overleaf saving, every single time you compile, or I think it's almost like Google Doc, it automatically saves everything. With regards to TextMaker, every single time you hit that quick build, it's going to save everything that you've done onto your computer. All right, and so there's a question now in the chat of how to import a .svg file. And these are files that would be created with Inkscape or some other vector file, which I can show you in a few minutes. However, I'll just show you how to include that right now. So it requires another package called simply SVG in order to import the file. And then what you're going to do is you're going to take your similar figure format, and let's call this Inkscape. And instead of include graphics, it's going to do include SVG. And I am going to specify Inkscape. So what you see here is this is just a small SVG file that I did. And I'm going to make that much smaller. And so that's the way you can include an SVG into your file. Again, would anybody be interested in seeing how you make SVG files or anything that's like in terms of figures? Would that be of interest?
Yeah.
Okay. So this is Inkscape. It is free to download online. So it's very user-friendly. It takes a while to get used to everything. But all you do is you create your image that you want out of circles and blocks, and and you continue that way. So that should be a circle. I have all my, one second. You can specify on the side what you want everything to look like, as well as transparency. And so what you can do is you can create some really neat figures. What I have here is this is actually, if you notice, math notation. And so what I could do is I could write a full fraction in here. Say AB divided by C. And what I do is I will save this. And then when you compile, it will actually put in that fraction in the proper math notation next to your figure. So this is something which makes it really nice to do something like a circuit diagram where you can put your resistance, inductance, anything like that in terms of your variables within it, and then just include it. And another important thing to note is as you scale your SVG file, your text is actually going to scale accordingly as well. So that's another benefit that you would see. Again, if you read that tips and tricks part of that document that's on Canvas, what you would want to do as you went through here, you can see how you have variables A, B, and C. So you want to say this figure is for blank. Variable A represents the so it's got to be very descriptive, your caption for each one. The only time you wouldn't have to put in the exact what every variable means is if you just introduced it in the text and then you reference to that figure. And then the other question is there a way to add a table of contents and page numbers? So I believe there is a way. However, in the report that we would like from you, we do not want a table of content in terms of that. There is a way to do page numbers on IEEE format. I will pull that up in 1 minute. So if you include the page style plain into your document, it'll auto format and put a page number at the bottom. All right, is there any other specific questions? Or if not, this is all I have for today. Feel free to stick around if you have any individual questions or anything further I can assist you with.